Now we're going to look at the divisibility rules for 4 and 8. And I really like these rules too. It requires that you just look at a couple of the digits. So a whole number is divisible by 4 if and only if the two rightmost digits represent a number that's divisible by 4. So you just look at the two digits on the right and you look at those as a number and you say, well, does 4 divide evenly into that number? If so, it will divide into the whole number. A whole number is divisible by 8 if when you look at the three rightmost digits, that represents a number that's divisible by 8. Now, I will say, admittedly, here you might have to break down and use a calculator, depending on how big the number is. But in class, if you were doing this in class, you would probably just use like long division to find out if something divides evenly. Because if you're going to pick up a calculator, it sort of defeats the purpose. So, one way that I can remember this, like whether you look at 2 digits or 3 digits or 1 digit, one way I like to think about this is these are all related to 2. Like 4 and 8 are both related to 2. So 2 to the first is 2. 2 squared is 4. 2 cubed is 8. And the reason why I'm showing you this is because if you want to find out if a number is divisible by 2, you only have to look at one digit. You look at the ones place. If you want to know if it's divisible by 4, you look at the right 2 digits. If you want to know if it's divisible by 8, you look at the right 3 digits. So there's actually a tie-in with the exponents here of how many digits you look at to figure out if a number is divisible by 2 or 4 or 8. So if that helps you memorize these rules, then by all means use that. So let's try divisibility by 4 first. Okay, I'm just going to do that column first. So we'll start with the number 832. For divisibility by 4, you just need to look at the 2 digits on the right. So I'm going to look at 32. And the question is, does 4 divide evenly into 32? And hopefully you can do that without a calculator. Yes, 4 divides 32. So that means 4 will divide 832. It'll divide the whole number because it divides the last 2. Now 1024, look at the last 2 digits. They make the number 24. Does 4 divide 24? Yeah, 4 times 6 is 24, so it divides it. So that means that 4 will divide 1024. It'll divide the whole number because it divides the last 2. And then if we look here, 14, the last 2 digits are 14. Does 4 divide evenly into 14? No. 4 does not divide 14. So 4 is not going to divide evenly into 514. So that's how you do the divisibility rule for 4. You just look at the last 2 digits. For 8, you look at the last 3 digits. So in this case, this is a 3-digit number. So this rule is a little silly with this one because you look at 832 and you say, well, does 8 divide 832? You're like, I don't know. That's what I'm trying to find out, right? But you could divide that with long division, and it does turn out that it does divide evenly with no remainder. So maybe the divisibility rule for 8 is better used when you have a number that's got more than 3 digits, because otherwise you're basically just doing long division. So, but it does divide. You can check it on your own, but it does divide. All right, how about 1024? You look at the last 3 digits, and the last 3 digits make the number 24. I know there's a 0 at the front. You just ignore the 0 at the front. Does 8 divide 24? Does 8 divide evenly into 24? Yes, it does, because 8 times 3 is 24. So yes, that means 8 will divide 1024. And we didn't have to do any long division to figure it out. And then for this last one, again, it's another 3-digit number. Maybe these weren't the best examples, but does 8 divide 514? If you try to do long division, you will find out 8 does not divide 514. So it wouldn't divide 514, or if you put any more digits above it, it wouldn't divide that number either. So it doesn't divide any number that ends in 514. So those are the divisibility rules for 4 and 8, and they are directly tied to the divisibility rule for 2.